What up, everybody? Welcome to lecture 4 of trig. Today we're going to be talking about section 1.5. To get us started, I wanted to go back to that idea of the unit circle that we've been talking about. I kind of wanted us to take a minute to step back and think about what the unit circle means when we remove the circle. Well, looking at it in this context, so the unit circle without the circle, right? It looks a bit like what we were talking about in that first lecture. An angle in standard position, right? The only difference is this time we know where x, y is. We know where that terminal end ends. And in this way, we can start recognizing cosine, sine, tangent as being defined on just any angle based on where it would lie in standard position. Having said that, let's look at a problem. All right, so for this first example, we're given an angle with a terminal end at the point -2, 5. And what we want is to find cosine, sine, and tangent. Well, we know cosine, sine, and tangent in terms of x, y, and r, right? R being our radius. But what we don't know in this particular problem is what the radius is. We're going to have to use these point, I should say. We're going to have to use this point to find the radius. All right, easy enough. We're going to take r is equal to the square root of -2 squared plus 5 squared. Calculating these squares out, what we're going to find is that r, our radius, is equal to the square root of 4 plus 25. Or just the square root of 29. All right, so we've got r. That means now we can just go ahead and calculate cosine, sine, and theta out in the traditional way. To start with, let's calculate cosine. Cosine of theta is equal to x over r. In our case, x is -2, and r is the square root of 29. Now calculating sine. Sine of theta is equal to y over r, which is going to be 5 over the square root of 29. And finally, tangent is going to be y over x, so 5 over -2. That's all she wrote. That's pretty much all I got for this example, I guess. So let's move on. All right, so to tackle the second problem, what we want to find is the coordinate of the tip of our terminal end of our angle. We want to find the radius of the terminal edge of our angle. And we want to find out what the cosecant of our angle is. And we want to find all of this out given that tangent of theta is equal to -5 over 4, and that cosine of our angle is greater than 0. All right, so how are we going to tackle this? Well, we can start by saying, I know that cosine of our angle is less than 0. And I know that cosine of our angle is equal to x over our radius. Well, because radius is always positive, that must mean that our x value is negative. So just from these 2 points, just from the fact that cosine of theta is less than 0, we automatically know that we can't be working in either one of those quadrants. Okay, that's convenient. Moreover, because tangent of theta is equal to y over x, we know we can't be working in this bottom left quadrant, because if we were, then x and y would be negative, and a negative divided by a negative would just give us a positive. So this tells us that our coordinates must be over here somewhere, right? But conveniently, we know that our tangent is equal to negative 5 over 4. So we can say that y is equal to 5 and x is equal to negative 4. All right, so we just found the first part of this problem. Now we need to find the radius, right? Well, to find that, we're just going to apply the Pythagorean theorem. I am not going to erase this. Nah, I don't need to. So to find to apply the Pythagorean theorem, I'm going to say the radius is equal to the square roots of negative 4, that quantity squared, plus 5 squared. Okay? This is going to come out to be the square root of 16 plus 25 or just the square root of 41. So now we know that the length of this is the square root of 41. I'm sure that's probably hard to see on the video. I was just writing it there just to keep track of what we've got thus far. So now all we have to do is find cosecant. Well, cosecant is 1 over sine. So since cosecant is 1 over sine, and sine is equal to y over our radius, and that must mean cosecant is equal to our radius over our y. Well, we already found our y, it's 5. We already found our radius, it's the square root of 41. So we can write this out. The cosecant of theta is equal to the square root of 41 divided by 5. That's all there is to this problem. It looks and sounds a lot more daunting than what it really is, but honestly, that's all there is to it. Having said that, let's look at another example. Before we get to this third example, we really quickly need to talk about this definition of a reference angle. All a reference angle really is the smallest angle between the terminal end of our angle and the x-axis. The smallest angle between the two. Having said that, let's look at this example now. In this example, what we've got is an angle of 300 degrees, right? We want to know what the reference angle is for that. Well, there's only 60 degrees in the positive direction to the x-axis, or in the negative direction, there's 120 degrees. So the reference angle here would be 60 degrees. Our angle is equal to 300 degrees, and our reference angle is equal to 60 degrees. That's really all there is to it. You're just saying, all right, I'm given some angle. Which direction is the smallest angle between the terminal end and our x-axis? Here, like I said, we had 60 degrees, and in this direction we had 120. Now we could have used any other angle we wanted. We could have, for example, had something like 170 degrees. Then we would have found that that angle was the smallest. Like, we could have gone with a couple different examples. Having said that, there are a couple of more examples in the notes. When evaluating the trig functions for any angle, we can make things a little bit easier on ourselves by following these 3 steps. First, we want to find the reference angle. Then we want to evaluate that function on the reference angle. And then we want to make sure our signs are right for whatever our actual angle is. Okay, that's a whole lot. What does that look like, right? So let's look at example 4. In example 4, we want to find the tangent of negative 7 pi over 6. Well, I don't know about you, but looking at this, I have no wild idea what negative 7 pi over 6 is in degrees. And I don't want to sit here and kind of figure it out, right? So let's go ahead and just put this in degrees because we're familiar and comfortable with degrees. Okay? So, really quickly converting that, negative 7 times pi divided by 6 times 180 over pi. Well, we can see the pi's are going to cancel. So we're left with negative 7 over 6 times 180 180 divided by 6 comes out to be 30. So this is equal to negative 7 times 30, or just 210, negative 210 degrees. All right, so we want to take and find tangent of negative 7 pi over 6. We now know that that terminal end is going to land wherever negative 210 lands, right? Well, moving negative 210 degrees, we're going to be right about here. It's going to look something like this now. Looking at this, you can easily see that the reference angle is going to be this angle here. This angle is 30 degrees. And because this angle is 30 degrees, and I know my unit circle, I know that cosine of 30 degrees is equal to 1/2. My mistake, I meant to say sine. No, cosine of 30 degrees is equal to square root of 3 over 2. Sorry about that. I totally just had a brain fart. Square root of 3 over 2. I also know, though, that sine of 30 degrees is equal to 1/2. And I know this, again, because I have the unit circle memorized. I know what the unit circle is. I can just throw these numbers down now. All right. So how might this help us? Well, we know that we're taking the tangent of negative 210 degrees. Negative 210 degrees is equal to sine of negative 210 over cosine of negative 210. Well, we're using our reference angle right now. So I can go ahead and apply the reference angle and say this is going to be sine over cosine. What we're going to find is cosine has to be negative, sine has to be positive. So this is going to be negative minus 8. This is going to be this 1/2 over negative square root of 3 over 2. So, because of this, rewrite this now as 1 over negative 1 over the square root of 3, or square root of 3 over 3. Okay, what did I just do? Well, we started by rewriting this in terms of degrees, just because it's easier to see, right? We're more familiar with that, so when graphing this, we kind of have an idea of what we're looking at now. Then saying, all right, cool, found the reference angle, it's 30 degrees. And using the reference angle in the unit circle, I was able to recall that the cosine of 30 degrees is the square root of 3 over 2, and the sine of 30 degrees is 1/2. And then because of all of this, I was able to say, all right, tangent of negative 210 degrees. Well, it's going to be like calculating the tangent of 30 degrees, but with the appropriate sign. And since I know cosine is going to be negative and sine is going to be positive, well, I can just go back to the 30 degrees, make cosine negative, sine positive, and calculate it the rest of the way through. That's all there is to it. play with these though. Again, there are more examples in the lecture notes that I posted online. Do a couple of these. If you have any questions, shoot me an email. Having said that, I think that's all I've got for y'all today. Have a good one, guys.